G'day, ladies and gentlemen. We are now going to be working our 10 problems from lesson 2.1a, solving linear equations in one variable. These notes will be on your Blackboard Quickly content. Very soon, the video of these being made are already on my YouTube channel, so check out the notes. And this will very soon be on my YouTube channel as well, 2.1a problems. So let's just remind ourselves that we have three different kinds of equations that we could be solving. The typical one is called conditional. It has one solution where we get something like x is 7. The second one is called a contradiction. It has no solution, and the way we know it is a contradiction is two things happen. Number one, the variable disappears. As we simplify the equation, the variable disappears, and what that means is there's the same number of x's, y's, or in this case z's on both sides of the equal sign, and we get a false statement. Obviously 6 is not equal to 2. That means there is no solution. The third type of equation that we can solve is called an identity. It's true for every single real number. It has an infinite number of solutions. And as we simplify the equation, we have the same number of variable on both sides. But when we simplify and eliminate the variable, what do you know? We get a true statement. So the two observations are the variable's gone and the statement we get is true. When that happens, we have an identity, which means it is true for all real numbers. Each of the equations we're going to be working now is one of those three types. So let's go ahead and check it out and see what we got here. All right, first thing we're going to observe here is I need to do a little bit of distributive. So I will distribute the 4. On the left side, it doesn't change. Multiplying by 4. I notice that I have like terms there. I can combine this, so now here is where we observed in our last video that once we get one side identical to the other, I know I have an identity. I don't have to go any further. I can go further and get 0 equals 0 if I want to. But identity. I have an identity here. So I know that this guy, the solution set is all real numbers. If I can think of it as another way, it has an infinite number of solutions. So I will go down and look at my options. No solution, one solution, or two solutions. Hey, I obviously copied this down wrong because this guy should be an infinite number of solutions. I choose that option, and of course they won't ask me for any examples because every real number is an example. So this is an example of an identity where one side of the equation is identical to the other. Solution set, all real numbers. All right, let's try the second problem. Notice I got me some decimals. As we observed in the notes section here, I can either just deal with this having decimals, or I can move every decimal place the number of times that makes every coefficient and number a whole number. And I notice if I move every decimal one place to the right, everything's a whole number. So I'm going to choose to do that. 3.5z becomes 35z, 3.6 becomes 36, 4.1z becomes 41z. Hey, that looks pretty easy. All my z's, or I should say more z's, are on the right, so I'm going to choose to get rid of these z's on the left. Whatever I do to one side, I have to do to the other. 36 is 6z. Obviously, I want z, not 6z, so I divide both sides by 6. Z equals 6. So my options, no option, no solution, nope. One solution, yes. So I'm going to choose this option. And as soon as I choose one solution, a box will appear. And it's going to say, okay, you see there's one solution. What is it? It's 6. I fill that in. Not too bad, not too bad. By the way, these problems came directly off of my Hawk's problems for 2.1a. They may not look exactly like your problems. And in fact, if I work my practice problems more than once, these problems won't show up again. Hawk's generates a new set of problems, but with the same look. So some of you may have exactly these problems. Congratulations. Others of you will have problems similar to this. All right, solve the following absolute value equation. We worked examples like this in the notes, and our first step was to isolate the absolute value. Please notice it's already isolated. Isolating meaning get it by itself. So the absolute value is by itself. I'm ready for step number 2. Step number 2 is to re-express the absolute value equation as 2 non-absolute value equations. And I simply do it this way. Whatever's in the absolute value, I set equal to the number, or whatever's in the absolute value, I set equal to its opposite. There are my 2 non-absolute value equations, and they solve very typically. My y's are obviously on the left side, so I'm going to get rid of the numbers on the left side by adding 4. Notice what you do once, you do twice, you do 3 times, you do 4 times, since the left-hand side of the equations are identical. 4's add to 0, I get negative 7y is 23. Or I get negative 7y is negative 15. All right, I need y, not negative 7y, so I'm going to divide both sides by negative 7. Not once, not twice, not 3 times, but 4 times. And here's where we need to remember that a positive divided by a negative, or you could say an odd number of negatives in an expression, there's only one negative, makes a negative. So y is negative 23 over 7. And that's as simplified as I need to write it, since no value other than 1 will divide evenly into 7 and 23. Second observation, if I have a negative divided by a negative, even number of negatives, that's a positive. So y is 15/7. Hey, I got 2 solutions. Very typical of an absolute value equation. So no solution, nope. 1 solution, nope. 2 solutions, yep. So I'm going to choose the 2 solution option. And as soon as I choose the 2 solutions option, a blank will come up and it's going to say, all right, what are the 2 solutions? And my 2 solutions are negative 23/7 or 15/7. Either one is a legitimate solution to this particular equation. Again, typical absolute value equation will have 2 solutions. All right, solve the following linear equation. Notice I got some serious distributive to do. Got to distribute the 6, got to distribute the 19. So I get 18w minus 18. And something I missed the first time I did this, that is negative 19. Negative 19 times 9 is negative 171. Negative 19 times negative w, positive 19 w's. All right, I've got numbers and w's on both sides, so I'm going to have to decide which side do I want to put my w's on. It doesn't matter, but to keep things positive, this side has more w's than that side, so I will put my w's over here just to keep things positive, which means I got to get rid of these w's. The way you get rid of 18w is to subtract 18w. Not from one side, but from both sides. Negative 18 is, I'm not going to write 1w, that's confusing, it's w. All right, this is my w side, so I don't need a negative 171 over here. I'm going to add 171 to both sides. Let me just encourage you, don't be too proud to use your calculator. 171 minus 18 is 153. Hey, a conditional equation, one solution, no solution, nope, one solution, yep. So I'm going to choose one solution. As soon as I do, it's going to ask me what it is, and it is 153. Hey, we're flying low here. Really moving on. All right. Hey, this will slow us down, if nothing else will. I got some fractions here. Let's remind ourselves of a good step for simplifying an equation involving fractions. That is, number one, identify the LCM, the least common multiple of all my denominators. I've only got one denominator, it's a 7, right? So the LCM of 7 and 7 is, let me think a minute, oh yeah, 7. So the least common multiple, the smallest number that will divide into 7 and 7 is 7. Step 2, multiply every term by 7. Every part of the equation, every term. Hey, and that means not just the parts that have fractions in them, but the parts that don't as well. So I'm going to multiply this by 7, this by 7, and that by 7. And to multiply by 7, since some of these guys involve fractions, I'm going to put the 7 over 1 to make it more obvious that I'm multiplying by 7. So I've multiplied this part by 7, this part by 7, and this part by 7. Why am I doing that? To cancel my denominators. Don't multiply up top, that's confusing. Let your denominators cancel. That's why we multiplied every part, every term by 7. So I have left 3 times z minus 2, I'll go ahead and write that out, minus 33, negative 5 times 7, negative 35. Little distributive. Let's see here, I've got some like terms. So I get 3z minus 39 equals negative 35. This is obviously my z side, so I need to get rid of this minus 39. The way you do that is do the opposite. Add 39 to both sides. Let's see, that's positive 4. Doggone it, it's not going to come out even, and you're going to get used to that with Hawks. They seem to have an affinity for equations that do not come out as positive whole numbers, like in the good old days. So, what do I get? 4/3. Z is 4/3. So I'm going to choose one solution. What is that one solution? It's 4/3. And 4/3 won't simplify. That's as simple as I can write it. All right, hey, another absolute value equation. Remember step number 1? Isolate the absolute value. It's not by itself right now, it's hanging around with a negative 17, so I get to get the absolute value by itself, and the way I'm going to do that is add 17 to both sides. Now I'm ready to do step 2, which is to express it as 2 non-absolute value equations. And the way I do that, whatever's in the absolute value equals the number, or whatever's in the absolute value equals its opposite. So solving these, I got to get rid of minus, I got to subtract 4 from both sides. Four z is 13, or 4z is negative 21. Divide both sides in each equation by 4. And these don't simplify, so I get z is 13/4, or negative 21/4. Hey, no 1 or 2. Yep, we've got 2 solutions. And those 2 solutions are 13/4 and negative 21/4. Again, equation with absolute value typically has 2 solutions. All righty. Number 7. Looks like I got to do some distributive first to get this guy simplified. So the left side stays the same, 9w plus 14. 9 times that, 9 times that, 9 times w is 9w. 9 times 6, 6 times 9, 54, minus 42. Now, as you work more and more of these problems, you're going to start coming to some mental conclusions early. Like, notice they have the same number of variable on either side. What I know is I'm going to either get no solution or everything's a solution. These w's are going to cancel. So I'm not going to get a conditional equation with a typical solution. Well, let's see what happens. Let's simplify, combine the like terms. Plus 12. Close but no cigar. The w's cancel. I get 14 equals 12. False statement. Notice, variable disappeared. False statement. 14 is not equal to 12. And whenever that happens, whenever these 2 conditions hold, the variable disappears in false statement, I have no solution. So my option is no solution. And when you put no solution, it's not going to give you a box because, hey, nothing works. All right, let's solve this guy. Obviously, some more distributive to do here. Left side stays the same. Then distributive, 5y plus 10. Minus 11. Look at that, same number of y's. We're getting used to this. Let's combine this first. The y's cancel when we subtract 5y from both sides, and I get 3 equals negative 1. A false statement. Hey, same as above. Same as number 7. The variable disappeared, no variable. I get a false statement. So my conclusion is no solution. Choose the no solution option. All right, they must have had a special on these at Walmart because Hawks has a bunch of these no solution problems. So let's see what comes up next. Hey, we got 2 more, 9 and 10. Fractions, absolute value. These are the challenging types, so glad we got one more example of each. All right, remember the first step? Look at your denominators, 5, 10, 10. Identify the least common multiple of your denominators. What's the smallest, the least number that will divide evenly, that 5, 10, and 10 will divide evenly into? 5 will go into 10, 10 will go into 10, 10 will go into 10. The least common multiple is 10. Secondly, multiply each term, each part, or you could say multiply the entire equation. Multiply by the LCM 10. And again, these are all fractions that I'm multiplying by, so I'm going to put the 10 over 1 just to make it more obvious which part is multiplied by the 10. And that's the numerator, the top of the fraction. Ten is multiplied by each part. And remember, don't multiply your tops. Let your denominators cancel. That's why we're doing this. We're multiplying by 10, not just to make things bigger, but to get rid of my fractions. Every denominator will cancel. 5 will go into 10 twice. 10 will go into 10 once. 10 will go into 10 once. So I have 2 multiplied by this. I'm going to go ahead and write it out so we don't miss the fact that I have some distributive here. 1 times 18 is 18. 1 times 16z plus 2 is 16z plus 2. Right, a little distributive here. 2 times 8z is 16z. 2 times negative 6, negative 12, plus 18. 16z plus 2. Like terms. Oh my goodness, they must have had a special at Walmart, because here's another one. Same number of z's, subtracting 16z from both sides, I get 6 equals 2, a false statement. So this is the same as numbers 7 and 8. The variable disappeared, get a false statement. What that says is no solution. So it doesn't matter if you got fractions, doesn't matter if you got absolute value, doesn't matter if you got neither of those. If the variable disappears and you get a false statement, you have no solution. All right, one last very important example dealing with absolute value. Step number 1, isolate the absolute value. It is not isolated, so I'm going to have to do that first. So I got to get rid of this plus 9. So here we go. Minus 9 from both sides. I get all right. If some of you are thinking my next step is to re-express this as 2 non-absolute value equations, you have missed an important observation. We went over this observation in the notes. Please note what you have here. An absolute value equals a negative number. One thing that we reminded ourselves of in talking about absolute values is absolute values are never negative. So my observation when I have an absolute value equals a negative is, hello, this never happens. I never get an absolute value equal to a negative number. And since it never happens, therefore, my conclusion is nothing works. No solution. So I choose the no solution option. Once again, anytime you have an absolute value equals a negative number, you can go ahead, you don't have to work anything out. There's nothing to work out. There's just an observation to be made. Since you have an absolute value equals a negative number and that never happens, there must be no solution. All right, that wasn't too bad. First set of problems is under our belts, and I will put these exact notes on Quickly Content and under Blackboard, and likewise the notes from 2.1a. And don't get behind. We got 3 sections due Thursday at midnight and 2 more sections due this coming Sunday at midnight. So get on it and stay up with each section and you'll do fine.